Now let's see this question. The 2 power n vertices of a graph G corresponds to all subsets of a set of size n in such a way that n is greater than or equal to 6, right? Now 2 vertices of the graph G are adjacent if and only if the corresponding sets intersect in exactly 2 elements. The number of vertices with 0 degree in capital G is dash and the number of connected components is dash. So they are asking about this. So what they are talking about the graph is, in this graph every vertex is representing a subset of n elements, right? So what I mean by this is, let's take a small example, right? If you take 4 elements, even though n is given as more than 6, if you take 4 elements, then how can you see it is, let us say there is a set containing A, B, C, D. Then they are saying that every vertex represents a subset of this set. So which means a vertex can be A, B, C, D, or a vertex can be A, B, C, B, C, D, C, D, A, all the sets containing 3 elements, or a vertex can represent any set containing 2 elements, which means A, B, B, C, like this, right? And now they are saying that if the intersection between 2 vertices is containing exactly 2 elements, then only they are adjacent, which means, see this, these two are going to be adjacent. This set and this set contains exactly 2 elements in their intersection, so they are adjacent. That is what they are saying. Now they are extending it to some number n which is greater than or equal to 6. Then they are asking this question, right? So the number of vertices with 0 degree in the graph is, right, and the number of connected components is. Now how to solve it is, let us assume that there are n elements, okay? Now with n elements, how many subsets will be possible? 2 power n subsets will be possible, right? Which means how many vertices will be there in this graph? 2 power n vertices, right? That is why 2 power n vertices is given. And now you can classify these vertices into different levels depending on the number of elements present in that subset, right? So one level is 5, which means the vertex representing the set which has 0 elements, right? Now if you see this particular vertex will not be adjacent to any other vertex. The reason is, if this has to be adjacent to any other vertex, then the intersection between these two sets should contain 2 elements, right? Now you cannot get 2 elements in phi. Got it? Since the cardinality of phi is 0, you cannot apply intersection of any set with phi and get 2 elements. Therefore, you cannot find any vertex in the graph which will be adjacent to this. Therefore, its degree will be 0. So the vertex representing phi will have a degree 0. Now at the second level, if you observe it, you will get all the vertices. See, I am classifying the vertices depending on the cardinality, right? So the vertex will contain single elements, which means A, B, C, like this, right? Something like this, so on. Now if you even observe these vertices, if you try to apply the intersection between these vertices and any other set, you are never going to get 2 elements. That is why even for all these vertices representing single element, the degree is again 0. Now how many such vertices will be there? Since they are saying that the set is of size n, there will be exactly n sets which are singleton. Therefore, for all those n, the degree will be 0, right? Now if you consider the next level is set the vertices representing the sets which have a cardinality 2, like this, A comma B, B comma C, C comma D, like this, okay? Now if you look at all these vertices, they will definitely be adjacent to at least one other vertex. If you don't know which one is, the simplest one you can assume is the set containing or the vertex containing all the elements. If you say the vertex is containing all the elements A, B, C, D, so on, all the n elements, then if you try to apply the intersection between this one and this one, definitely the intersection is 2, therefore they both will be having adjacency. So right, Now similarly you can find out that every set which is containing more than two elements will always be adjacent to one of these vertices. The reason is, if you have any set which is containing more than two elements, that would have been formed by taking any of these sets. Got it? Therefore every other vertex which can contain either three, like this, will be adjacent to this, or if it contains four, let us say ABCD, will be adjacent to this, right? So only vertices which will have a degree 0 is, one is vertex representing 5 and the other one is vertices representing singleton sets. So n elements and then one element, therefore n plus 1 elements, n plus 1 vertices will have 0 degree. Now what about the connected component? Definitely all these isolated vertices are going to form n plus 1 components, right? Now how many remaining components will be there? All the remaining vertices are going to form one big component. How to see this is simple way. I told you that all the vertices representing two element sets are directly connected to the vertex representing all the elements, right? And every other vertex, any other vertex other than these which are represented here, will definitely be having a connection with these, right? Therefore you can say that all of them are somehow connected to this. Are you getting this? See, what I mean to say is, if you represent all the elements of the set like this, 1 2 3 so on n, right? Now I am saying that the elements or the vertices representing these two elements, 1 comma 2, 2 comma 3, like this, they are all connected to this, right? And every other set which you can imagine will definitely be connected to one of these. Therefore from any set you can reach any other set by passing through this and coming through this. Therefore all of them are connected through this main set, right? So they are all going to form one connected component, right? So already we have n plus 1 isolated vertices and we have one big connected component containing the remaining elements put together. So the number of connected components is going to be n plus 2. Got it? Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have, you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.